Here we're asked to evaluate these expressions using a calculator. So we'll certainly be reaching for that. And maybe you already see that in each case, we don't have perfect squares or perfect cubes that we're dealing with here. So that's why we're reaching for that bit of assistance. Couple ways to do it. We can take an expression like 29 to the power of a third and write that as the cubed root of 29. Now you have the choice of evaluating this as an exponent or as a radical. Remember that if you're evaluating as an exponent, you're probably going to need some brackets. For an example like this, in my calculator, I'll punch in 29 and various exponent buttons. Mine happens to have a caret. I tend to call it a hat. And now because I want to raise it to the power of 1/3 and not just 1 and then divide by 3, I'm going to open a bracket. I can now hit 1 divided by 3 or 1 and then the fraction key 3, whichever is easier for you. Or again, once you've rewritten it as a radical, this really is just the cubed root of 29. In any case, to 2 decimal places, the solution is 3.07. Similarly here, I'm probably going to drop this into my calculator as is, which means I'm going to raise it to the power of, so maybe you have this button, or maybe it looks something like this, y to the power of x. And in any case, find your exponent button, and then raise it to the power of 2/3 by taking 2, dividing it by 3 within those brackets. What we should get is 5.24. So these aren't tricky necessarily, they're teaching us how to use our calculator. What we do have to be clear about is translating brackets into our question, or rather inputting brackets where they're given. In these next 2 problems, it's critical. Let's start with negative 17 to the power of a half. Again, if you drop that negative 17 into brackets first and then raise it to the power of a half, that won't work because you can't take the square root of a negative number. But the negative 17 isn't in brackets, so don't enter it that way in your calculator. It's the 17 exclusively that's raised to the power of 1/2. You don't need to show an intermediate step here. I'm just illustrating what my thought process is and also what I'm entering into my calculator. So 17 to the power of 1/2 is 4.12, and I'm multiplying that by the negative 1 out front. So negative 4.12 is my solution. Now I intentionally skipped over this one. Many calculators have a hard time dealing with this problem. Even though it's mathematically legal to do so, sometimes we get an error. What we're being asked to do here is take negative 2 and find its cubed root. And of course, you can take a cubed root of a negative number. But sometimes your calculator won't allow you to do this. One way to get around this is to rewrite it using radical notation. So we're taking the cubed root of negative 2, and once we have that, we'll raise it to the power of 2. Try this with different calculator models if you have them. This is one of those instances where sometimes those calculators will let us down, and knowing how to rewrite that exponent as a radical actually is the only way to get to our answer. So as we expected, our final answer will be positive because although the cubed root of negative 2 is a negative number, negative times negative, which happens when we square it, gives us a positive value, and to 2 decimal places, that's 1.59. We just have one more example here where we've got a negative exponent. So because that negative exponent will give us a 1/3, it'll take the reciprocal of 3, we should expect a small number here. And in fact, we get 0.11.